Hi, we are the Learning Analytics team. Our team members are Nick, Jack, Lee, and Ryan. Our mentor was Santosh Kasula, who was able to help guide us through our project by giving us advice on design decisions as well as team productivity and organization. In this video, we are going to cover the following topics. First, an overview of our project, including the motivation and problem that needed to be solved, including how we approached the problem and the team goals for the project. In addition, we would like to talk about the work we were able to accomplish, including the work we did on our front end and our back end. Finally, we would like to walk you through a demo, as we walk through as an instructor on the front end and as someone who is interacting with the API from the command line. And lastly, takeaways about what we learned and the limitations of our project, as well as future plans that we have. So what is learning analytics? We knew that all the major learning management systems have some sort of online assessment component and analytics built on top of them. There's not much progress made on these analytics for programming assignments though. These online platforms are collecting a lot of data about how a learner is solving programming assignments, but there is not much feedback provided neither to the learner nor to the instructor based on that data. Therefore, the focus of this project is to analyze programming assignment data and visualize useful patterns for instructors and learners. We would like to answer questions like, what are the different ways to solve a problem? Where is my class struggling? And what solutions are different from the rest and why? In addition, throughout the process of creating this product, we would like to learn the new technologies relevant to web frameworks for Node.js, data visualization with D3, client-side JavaScript with React.js, as well as some database information with MySQL.
Our solution consists of three components working together. The first is a simple and clean interface containing a 3-level drill down, allowing for quick identification of outlier solutions. The second component are the analytics we provide. From talking with instructors, we identified 4 useful metrics: the number of incorrect versus correct solutions, the number of lines, the code size, and the number of attempts until correct. The last component is our backend analytics engine, which parses MATLAB submissions and provides metric data to the application. Here is the list of the technologies we used in our implementation of the solution. Some noteworthy ones for the front end are HTML, JavaScript, D3, Ajax, jQuery, Gulp, and Reactify. And on the back end, SQL, Node.js, and HTTP routing functionality were major pieces for the analytics engine. Our goal is to provide teachers access to useful analytics about their class's performance to enable them to more effectively understand their students. In light of this mission, our app should support 3 main features. First, aggregate analytics, which describe the class as a whole. Second, statistics on subsets of the data, as well as individual student solutions. And third, all of this is to be implemented behind a visually pleasant, simple, and intuitive interface. Furthermore, our app should support 3 analytical dimensions: students, metrics, and assignments. This means that the teacher can view graphs comparing different students or various assignments for any selected metric. Lastly, the backend infrastructure should support this functionality by implementing and exposing a streamlined API. In all, our product should be a standalone web application hosted on the cloud.
We have developed a dynamic and simplistic UI. We really wanted to offer few decision points for our users to boost intuitiveness. Our application front to end is entirely in JavaScript. We have utilized a variety of frameworks. In traditional JavaScript, we've written custom data structure implementations for features like the student search box and the forward and back functionality. We've also written many object-oriented relationships and have written clean and modular code. There were times we even needed to reverse engineer libraries for design functionality, such as for graph color and event handling. We want our users to navigate the app with ease, so clickability has become a large part of our visualizations. This is what makes a drill down feature possible. Welcome to Learning Analytics. Our homepage states our mission, as we are very committed to create a simple to use and powerful analytics platform. We've come to realize that teachers want to know more about their students' code, rather than just whether or not it's correct or incorrect. So, First, I'm going to dive into our teacher view, show you what our web app looks like. At Learning Analytics, we're aware that professors are curious about how their class has performed as a whole. So, we've offered them a feature that caters to that. With a simple drop-down, teachers can select from 4 different metrics as well as a variety of their assignments. And these graphs will update depending on whatever the active assignment is. Learning Analytics also helps conduct office hours for educators. Say a student was wondering if they were approaching the problem correctly. We allow all professors to open up the incorrect submissions for the given assignment. That way, they could look at the particular student's code. From the MATLAB teaching assistant that we spoke with, we learned that educators are very interested in outliers. So, our graphics make it quick and easy to identify outliers and see what makes them so peculiar.
And now our backend. First off, the server. For the server, we decided to go with Node.js and the Express framework. One of the reasons for this is that we had a few group members who had previous experience working with Node.js and Express, and we hope that the experience would carry over to the current project. Another reason is that we thought it would be easy to get an Express application up and running quickly. We didn't see that we would have a ton of time to work on during the semester, so we put the utmost importance on getting an application up and running so that we can develop features as quick as possible. Lastly, we chose Node.js because we didn't necessarily need a framework with a lot of bells and whistles. Node.js would provide us with a RESTful API and a connector to a SQL server, and this is all we needed for most of the features of our application. For our database, we decided to go with MySQL. One of the reasons for choosing MySQL is because it fit the data well. We needed a relational schema based on the data we were provided by our mentor, so SQL was a good idea. Another reason is that MySQL had the capability to scale well vertically, and if we were ever to turn this into an app which would potentially see a lot of users, we were confident that MySQL would be able to handle the job. Also, a few of the group members already had experience working with SQL, so it made app development easier. Lastly, we have our hosting. Hosting was a simple choice for us. All of us agreed on going with AWS and putting up an Ubuntu virtual machine to run the server. We had worked with AWS before, and we all recognized that it was easy, simple, and we would get the benefits of hosting our server in the cloud. Next, we have our implementation. One of the first implementation details was how do we get the JavaScript, HTML, and CSS to users who want to visit the site. We did this by having Express serve a public folder which contained all these and would be publicly accessible by anyone communicating over the internet. Another feature we implemented were RESTful API calls. The RESTful API calls were the way that the backend and the front end communicated in our app. When the front end, in this case a user, wanted to receive metrics or data on the solutions, they would make RESTful API calls to the server through their web app. These RESTful API calls would then be returned to the front end, containing the solution data and the metrics. These data and metrics originated in the MySQL database. We had Express connected to the MySQL database so that when it received requests, it would be able to pull the data that we had stored previously and return it in response to the user. These metrics were generated through Node.js scripts. These Node.js scripts, however, were not the same as our server backend. They were scripts that would be run a single time manually whenever we wanted to generate new metrics, often based on new data which had been inputted in the database. This was part of our implementation idea. We thought that generating metrics offline instead of whenever a user requested would result in a performance increase. This is because some of the metrics were computationally intensive, and this meant that if we recompiled the metrics every single time a user made a request, it would cause significant strain on the user. By storing these metrics in non-real time, we were able to achieve better performance whenever a user made a request to the server. And now a quick look at the architecture. Here we can see the divide between the browser, which is front end, and our backend, which here is titled Amazon Web Services. The browser contains all the data which is stored locally by the user whenever they request the web page. And then our Amazon Web Services section shows the stuff that is stored in our Amazon EC2 instance and is associated with the running server. You can see that these two communicate with each other via the RESTful API over HTTP. Now we are going to walk through some of the backend functionality of running analytics software. To test this functionality, we are going to interact with the RESTful API via the command line. First, we will test the endpoint that returns correct and incorrect percentages for a particular problem. This is an example of an endpoint that returns accurate metrics for all solutions to a particular problem. Next, we will test line count. This endpoint returns a bin set of data for all solutions to a particular problem. This type of metric is what we refer to as a solution level metric. Finally, we will test the endpoint that returns the first correct solution a student has submitted. This endpoint takes in both the problem ID and student ID, and is what we consider a player assignment level metric. Overall, the backend was built efficiently to support the front-end need to drill down into a problem, offering metrics at different depths.
Here are our top takeaways from the project. First of all, we learned how to develop and build out a web application. We understood the importance of user stories in crafting the solution, as well as the finer points of user interface design. We realized the power of team tools such as Git and Trello, which helped us manage our time and work together efficiently. We also learned that taking time at the beginning to plan out our path saves much time and headache after. Tasks in reality take much longer than originally anticipated, and we learned how to compensate for that. And in general, we learned to be flexible and agile throughout the entire development process. As for our limitations, at a high level, we decided to solely focus on the teacher's portal, instead of building out additional perspectives, such as a student view. If given more time, we would have liked to implement scaling solutions, as well as enable the analytics engine to update in real time, as new data is submitted and received on the back end.
We have some future plans about what could be done with this project. First is to build out the student portal. This semester we mainly focused on the experiences of the instructors because we thought instructors would stand to gain the most from analytics. However, we recognized that there are many reasons why students may potentially be interested in seeing metrics on their performance in the course. So we would hope in the long run to add some other features which would benefit the students. We also have ideas to build out a submission portal. A submission portal would be a way for people to submit answers to the MATLAB problems and have them accepted to our database. This will allow us to dynamically update metrics and provide a real-time view at the performance of classes. Another feature which could be implemented was load balancing via Elastic Beanstalk. This also ties in with another plan, which is to move from SQL to Amazon Web Services RDS storage system. These two are very important for an app in the long run because our original implementation just involved a server stood up in a single Amazon EC2 instance. We think that If the app were developed more, it would face much larger load strains and need a much more robust system. We think that by switching to Amazon's RDS and by implementing Elastic Beanstalk, our application would be able to scale much better. And now the wrap-up for our project. In one sentence, we created an analytics web app that connected with a cloud-hosted server and a cloud-hosted database. To implement our project, we viewed it from the customer's perspective. This included user stories, which allowed us to understand the customer's motivations for wanting a certain feature. This also involved understanding an intuitive user experience flow. This meant that we had to step back from the app and look at it from how a user is going to interact with it and make changes that would allow us to streamline the app and make sure that a user progressed through our application as smoothly as possible. Our project was developed in a sequence of very short but also intense development cycles. These were a keystone of the Scrum and Agile development process which we had learned throughout the course. And it involved us doing weekly stand-ups and weekly mini hackathons in order to get our application complete. We also harnessed some very useful tools which allowed us to collaborate as a team. This included version control using GitHub, planning through Trello, and communication through GroupMe. And we would like to give a special thanks to our mentor for this project, Santosh Kasula at MathWork. He was incredibly helpful in our project and gave us some ideas which we had a pleasure working with over the course of the semester, and we are very glad that we had him.